All right, so let me clean those rules. Please note them. When the questions get tougher, you will find them tough. Now, when we are considering approximating areas, first they are talking about the areas. What happens to the areas under a curve? Like we have a graph, right? And this is the x-axis, right? And this is the y-axis, right? So now there is a curve that comes here. First, we know that any point in this curve is a function f of x, which is equal to y. Like I told you when we were doing calculus in your first level, like in your first semester, I told you. Now, while we consider, we already know the functions, the value of the functions. The difference between this and that calculus that you learned there was that here they've given us the values of the function at each point, or we are going to find it by the formula. But now we don't know what happens under the curve. So our mind is, can we approximate? Because whatever we are doing, we are the one generating our constants for areas under the curve. And what medium can we use to evaluate our areas? Since we are approximating, what mediums can we use to evaluate our areas under this curve? Then two things came to our mind, right? So since this is the curve and any point in this curve is by f of x, I have to think, let me take a point, because this is assumed to be 0. Let me take a point on the x-axis, and I call that point point A. Let me take another point on the same x-axis, and I call that point point B, right? Now, I'll draw a line from here, from a line that must be touching the curve, and then a line from here that must be touching the curve. Now, I want to partition this box, the space here, the whole of the space here. I want to partition it. Note what I'm doing. I'm giving a first partition. I'm giving a second partition. The distance between here and here is the displacement, which is the x. You know, in differentiation, when we're doing first calculus, I told you that the x means change in x2 minus x1. Remember? So instead of them to take change in this, let's just say here is x1, right? And this next part is x2. Instead of us to say x2 minus x1, we just say dx. And why are we using only one constant? We are using only one dx because the distance between here and here is the same as the distance between here and here. Also the same as the distance between here and here. Note one thing, write this thing down, note it. Note it will help you. Dx remains constant. I think you might want to jot this down, it will help you. So any value you get for this partition that you assume, because they say approximating, so any value you get for this partition is constant, it doesn't change. So what changes is the height. Let me show you how the height changes. If I from here I meet here and I cross it over, because this touched here, and I cross it over, I get a rectangle. Then from here I meet here and I cross it over, I get a rectangle. Are you seeing what's happening? From here I cross it over, I get another rectangle. If you notice, the height between here and here, h, let's just say h1, is different from the height between this rectangle here and here, h2. Have you seen it? So what is changing here? What is changing here is the height. Now, let me tell you how they came about rectangle. They used the rectangle, like we are using rectangle here, because rectangle is the only shape that the area is very simple. Rectangle area is just what? Length times width. Sorry, area of a rectangle is length times width. Now the width is constant. Width is constant, which is what? That the x I told you. Do you get? Then the height changes. Yeah. How do we get the height? You notice that the height is different. The height is gotten from their graduations. Remember that this is 0, right, on the displacement, right? And there are some partitions that are left. There are some partitions that are left here for right angle. There are some partitions left here, right? So if you're considering this thing, we have left here to here. We are assuming that this point is now x1.